Welcome to another video by SmartPath Tutoring, GCSE Physics. Today's video is about resultant forces and work done. Free body diagrams show all the forces acting on an object. You need to be able to describe all the forces acting on an isolated object or a system, page 11. For example, every force acting on the object or system, but none of the forces the object or system exerts on the rest of the world. For example, a skydriver weight acts on him, pulling him towards the ground, and drag air resistance also acts on him in the opposite direction to his motion. This can be shown using a free body diagram like the one on the right. The sizes of the arrows show the relative magnitudes of the forces, and the directions show the directions of the forces acting on the object. A resultant force is the overall force on a point or object. In most real situations, there are at least two forces acting on an object along any direction. If you have a number of forces acting at a single point, you can replace them with a single force, so long as the single force has the same effect as all the original forces together. This single force is called the resultant force. There is a downwards resultant force acting on the sky driver above. If the forces all act along the same line, they all are parallel. Then the overall effect is found by adding those going in the same direction and subtracting any going in the opposite direction. For example, for the following free body diagrams, calculate the resultant force acting on the van. Consider the horizontal and vertical directions separately. State the size and direction of the resultant force. For the vertical calculation, 1500 neons take away 1500 neons is equal to 0 neons. For the horizontal calculation, 1200 neons take away 1000 neons is equal to 200 neons. Answer: the resultant force is 200 neon on the left. If a resultant force moves an object, work is done. When a force moves an object through a distance, energy is transferred and work is done on the object. To make something move or keep it moving, there are frictional forces. A force must be applied. The thing applying the force needs a source of energy like fuel or food. The force does work to move the object, and energy is transferred from one store to another. Whether energy is transferred usefully, for example, lifting a load, or is wasted, you can still say that the work is done. Just like Batman and Bruce Wayne, work done and energy transferred are the same when you pushed something along a rough surface, like a carpet. You are doing work against frictional forces. Energy is being transferred to the kinetic energy store of the object because it starts moving. But some is also being transferred to thermal energy stored due to the friction. This causes the overall temperature of the object to increase, like rubbing your hands together to warm them up. You can find out how much work has been done using work done is equal to force times distance. 1 joule of work is done when a force of 1 Newton causes an object to move a distance of 1 meter. You need to be able to convert joules of Newton meters. 1 joule is equal to 1 Newton meter. Thank you for listening.